Hi guys, so I did question 43 for chapter 5. So I started by drawing the diagram that kind of came with the question. So you had M1 and M2 connected with a string, tension T, pulled to the right with an applied force of 68 newtons. So M1 is 12 kilograms, M2 is 18 kilograms, and there's friction, and the mu constant, which they give to you, is 0.1. So for the first part, they have you draw some free body diagrams. So I also had up as the positive y direction and right as the positive x direction. So for M1, you have friction to the left, tension to the right, and the gravitational force M1g, and its corresponding normal force. And then for M2, you had tension to the left, friction to the left, and the applied force to the right, 68 newtons. And then in the y direction, you had for M2 the gravitational force M2g, and then its corresponding normal force. And then for part B, they had you solve for acceleration and tension. So if it was just acceleration, you could just add the masses and you could be fine, but you also have to find the tension, so you have to do all this. So for M1, you have the sum of forces in the y direction, n minus M1g equals 0. 0 because it's not moving in that direction. So n equals M1g. And then in the x direction for M1, you have T minus friction equals M1AX. And then for M2, you have in the y direction n minus M2g equals 0. And n equals M2g because it's not moving in that direction again. So then in the x direction for M2, you have the applied force minus tension minus friction equals M2AX. And now you have a system of equations because you can solve for friction because you have the constant and the normal forces. So and then you have two unknown variables, acceleration and tension. So you have these two equations over here. And I chose to solve for acceleration, so I set this equation to tension and this one to tension, and I substituted. So tension equals M1g mu plus M1AX. And then on this side, tension equals 68 newtons minus M2g mu minus M2AX. Then you set them equal to each other, and then you solve for AX, which is 1.29 meters squared. Meters squared. And then you can plug in this value to find tension for one of these equations. So I just chose this one. I brought it down. T equals M1g mu plus M1AX. And then when you plug in all the values, because you have them, you get tension as 27.2 newtons. Cool.